Okay, another type of reaction is combustion. So combustion is when oxygen combines with a substance and releases energy in the form of heat and light. So combustion usually only has the elements C, H, and O. The other thing you might see, but this is also classified as a synthesis reaction, something like sulfur plus oxygen yields SO3. So you could classify that as a synthesis reaction. Some people also classify it as a combustion reaction because you are combining oxygen with another element. So just something to be aware of. However, if you see a reaction with only C, H, and O, it will be the same products every single time. So every time you're going to get CO2 plus H2O, carbon dioxide and water. It's never going to change as long as it's only CH and O. So you might have a CH compound or a CHO compound plus oxygen. Those are the two most common. So an example of a combustion reaction would be like a car engine, a sparkler, that's a combustion reaction. Notice you're releasing energy, you see that light. All right, so these are some example reactions. What's interesting about combustion reactions is that there is a set way to balance them. So you always balance in the same order alphabetically, CHO. So I'm going to show you that. And I'm going to use my reactants and products chart. So I have 4 reactants, 1 product, 10 H's, 2 H's, 2 O's, and be careful, there's O's in 2 spots here, 3. All right, so balance your carbon first. That changes my carbon to a 4, changes my oxygen to 8 plus 1, which is 9. All right, hydrogen, I need 10, so I need to change this to a 5. That makes this a 10. Again, changes oxygen. 5 plus 8 is 13. This is where it gets problematic because we have an O2 and we need to make 13 out of it. So do not do this for other reactions, but for combustion, you can put a half as a placeholder. So let's put 6.5, because 6.5 times 2 would give you 13. Now, in order to balance this, we take the entire reaction and we multiply by 2. So our final answer would be 2C4H10 plus 13O2 yields 8CO2. Oops, sorry. Plus 10H2O. So again, I multiplied every single coefficient by 2. All right, next one. CHO. So we have 3 carbons, 1 carbon. 6 hydrogen, 2. And then again, be careful, you have oxygen in 2 spots, 3 and 3. All right, so balance my carbon first with 3, makes that a 3, changes 6 plus 1 is 7. Hydrogen, I need 6, so let's make that a 3, changes this to 6. Then we have 6 plus 3, which is 9. Okay, now, do not use this oxygen to balance because you're going to mess everything else up. But don't forget to take it into account. So I have 2 oxygen here, I have 1 here. So I need a total of 9. So what theoretically you could do is say 9 minus 1, this 1 oxygen. So I need 8 more, so that makes this one a 4. So that would be balanced, because now there's 8 plus 1, that gives us 9. So your coefficients would be 1, 4, 3, 3. So that's kind of how you would balance them. All right, now our next thing we're going to do here You're going to predict the products and balance. So hopefully you remember that all the products are the same. So they are all CO2 plus water. I recommend pausing the video, try balancing them, and then checking your answers. Okay, so these should be your answer. Your first equation should be 1, 2, 1, 2. Second equation, it was an instance where you should have doubled everything through in order to balance out those oxygens. So you end up with 2, 3, 2, 4. And the last example, you should have 1, 6, 6, 6. So again, combustion reactions, they always are going to have the same product, CO2 plus water. And just remember, you could have a combustion reaction that's also a synthesis reaction. So just something to be aware of.